welcome to CEC lectures. In this series of operating system concepts, we have previously seen the page replacement techniques, what are they and how they are useful, and we have also seen one page replacement technique which was first in first out in our in detail. And now today we will be looking into more page replacement techniques and other concepts related to this page fault thing. So before beginning the lecture formally, let me welcome you all. I am Dr. Preeti Jagmani from Department of Computer Science, Aryabhatta College, University of Delhi. So today's lectures start from our second strategy of page replacement techniques, which is known as optimal page replacement. And as we say optimal page replacement, that means there is a strategy which is going to give me the, we can say, most efficient results. So here what is the idea behind this replacement techniques is pages are replaced which would not be used for the longest duration of time in future. I am repeating it here. Pages are being replaced which would not be used for the longest duration of time in the future. How this is going to be implemented, let us see this with the help of an example. Here is the example which is being shown on the screen. We have a page reference string as 701-203 04 230 323. There are kind of some requests which is for different page frames, different pages, and number of page frames is 4. And as we are talking about demand paging that we have seen in our earlier example, also we have 4 frames. So the 7 no frame available, it is going to give us a miss. Then again 0, it is going to give us a miss because it is not available. Then 1, again a miss, and 2 is again a miss. Now what is happening here? The 5th frame which is being asked for is 0. Now 0 is going to give a hit. Then we have 3 which is being asked for. Now we are going to replace 7 by knowing the fact that 7 is not going to be kind of used for the for in future for a long duration of time. Then the reference string says there is a request for 0, 0 is already available, then it is going to be a hit. Then we have 4, 4 is obviously not available, and we are replacing here we are replacing 1, that means 1 is being swept out, assuming or knowing the fact that 1 is not going to be used for a long time in future. Then 2 is being asked for, 2 is going to give us a hit. Then 3 is being asked for, 3 is going to give us a hit. 0 again a hit which is available, then 3 a hit, 2 resulting in a hit, and similarly 3 is also resulting in a hit. So here we have kind of, we can say, very less page faults, which is total equals to number of total page faults is equals to 6 here. So we have used the strategy that we are going to replace the page which will not be used for a longer duration of time or maybe for a long duration of time in future. But please wait, is it actually we can say possible to know which particular frame is going to be used, which particular page number is going to be used after how much time in future? So basically optimal page replacement as a strategy, if we see, it is perfect, but practice wise we can say it is not possible, because the operating system cannot know the future request. It is not possible to be aware for the future request that when and which particular page is going to be required. Now then why, if we can say it is not practically possible, then why there is a strategy which is coined in the name of optimal page replacement strategy. Now the use of optimal page replacement strategy is to set up a benchmark so that other replacement algorithms which are kind of being devised, they should be analyzed against that particular benchmark. So, for example, consider this reference page reference string. So, with this page reference string, if one of the techniques is going to give us a total page fault of 6 when total number of frames is 4, obviously that means in the similar conditions, if any of the page replacement technique is going to give me total page fault as 6, we can say that is going to be the one of the optimal page replacement algorithm. So, this is basically used as a, we can say, benchmark, so that other replacement algorithm can be analyzed against it. So, that is what we can say is the use of the optimal page replacement, because in practice, or we can say in reality, it is not possible to implement this kind of a page replacement technique, because we are aware that the operating system somehow will not be aware or cannot know the future request related to this particular system, or the future request of the processes which are there. So, till this point we have seen two page replacement algorithms. One is the optimal page replacement algorithm, another one is the first in first out page replacement algorithm. Now, next which we are going to use is LRU page replacement algorithm. LRU page replacement, LRU here stands for least recently used. Now, in this algorithm, the page which is being replaced, the page will be replaced which is least recently used. That page is going to be, we are going to replace that. Now, consider the similar, we can say the reference string with total number of page frames 4, but with a different strategy of least recently used. So, starting from 7, so we have 7, we have 0, then we have 1, then we have 2. All these page frames give us a miss, because earlier nothing was there in the physical memory thing. Then asking for a 0, it is going to give us a hit, because 0 is already available. Then when we talk about 3, now 3 is not available. What is available is 2, 1, 0 and 7. So, if 3 is not available, we are going to replace 7, because that is the least recently used, that is not being recently used, we can say. So, 3 is going to give us a miss. Then 0 is already available, that is going to give us a hit, 0 is available. Then we say 4 is going to be a miss, and we will be using you can say 1, because it is something which is least recently used as far as this example till now is concerned. Then we have a 2, it is a hit. Then we have 3, again a hit, and 0, 3, 2, 3, all these are resulting in hits. So, what is happening here? If we count the total page fault, the total page fault is 6. So, yes, that was the kind of, actually we can say, performance which we were looking for. If you remember, in optimal page replacement algorithm, I told you that this is going to be the benchmark, or the performance of your optimal page replacement strategy will be used as the benchmark. And for this particular example, the total page fault which was given by the optimal strategy was 6, and LRU is also resulting in 6. But here the LRU is having the same number of page faults as the optimal strategy, but this may differ according to the question. But yes, from one example we can say the less recently used LRU page replacement algorithm is something which we should keep an we can say an eye on, or which we should keep an watch, which could be one of the possible we can say possibly best algorithm which can be used for page replacements. Another one, the algorithm is most recently used algorithm. So, most recently used the short form is MRU. MRU, most recently used. In this algorithm, the page which has been used recently will be, we can say, replaced, will be, taken out. But the point here is the Belady anomaly can occur in this algorithm, and we have also, we have seen that what is Belady anomaly, that is with the increase of number of frames, the number of page faults is going to be increased. This can happen in first in first out, and also this can happen in most recently used MRU algorithm as well. So, this is one of the disadvantages of most recently used algorithm, that Belady anomaly can occur in this. Now, so with this we have seen 4 page replacement techniques. So, practically 3, and one is considered as benchmark. So, one is first in first out, another one is least recently used, and the third one is most recently used. And in order to kind of compare them with a level, with a benchmark, there is a strategy which is optimal page replacement strategy. So, this was actually about uh, swapping in and swapping out of pages, selection of we can say selection of victim pages. But apart from this, if we can say, if we can see some other technicalities in this whole strategy, is one point which is worth noting down here is about frame allocation. Now, what is happening in a page, this whole mechanism of swapping in and swapping out, a frame allocation algorithm must be created. If we are considering the situation of demand paging, then along with a page replacement mechanism, there must be an algorithm which is for the allocation of frames. Now, frames are basically, we can say, or these there are these holes or indexes where the content of these pages, or where these pages are going to be copied in, or where these pages are going to be loaded in. So, frame allocation techniques are utilized in order to determine how many frames to provide it to each process. So, let us say, for example, we have seen in the previous examples of page replacement techniques, somewhere we have seen there are 4 frames, and somewhere we have seen there are 3 frames. So, how many frames are to be provided to each process? That is something kind of very that is something which is very answer should be which is there is something which is to be answered very, very carefully. So, basically we can say one idea is you can allocate all the processes with equal number of frames, or you can have unequal distributions of the number of frames. Now, in case of unequal distribution, the question comes up, which particular process is going to get how many frames, and so on and so forth. So, so the one thing which is very, very clear is, apart from page replacement algorithm, something which is related to frame allocation technique, that also has to be kind of very carefully considered, and there are many constraints which are associated with this frame allocation. So, the frames, we can say, first constraint says in any case the total number of the frames allocated to all the processes cannot be greater than the total number of frames available. Obviously, if we are going to have 10 frames in total, and we have 3 kind of processes, and let us say we want to allocate 4 frames to each process. So, that is not possible, because how can we allocate 12 frames out of 10 frames. So, that is one constraint, that frames cannot be allocated which are greater than total number of frames. Now, each process should be given a set minimum amount of frames, minimum number of frames. So, obviously, that minimum threshold has to be there, otherwise at one particular point of time there will be a process, there may be a process which is not having even a single frame. So, that process cannot continue with its execution. Now, when fewer frames are allocated, then the page fault rate will increase, and the process execution become less efficient, that is there. So let us say we have 20 frames total, and we want to keep the degree of multiprogramming is 10, and all the 10 processes are given only 2 frames. So that is something which is very few. Logically it is not okay to have only 2 frames. So fewer frames are allocated to the processes will result in increased number of page faults, and obviously with the page faults your execution is going to be less efficient with time. So that means there ought to be sufficient frames to accommodate all the many pages that a single instruction may refer to, because in a single instruction, while executing a single instruction, it is not a good idea to have page faults again and again. So in a single instruction, if we are going to have multiple page faults, it is going to hit the efficiency of the system very hardly. So that means there ought to be sufficient frames to accommodate all the many pages that are required for a single instruction or that a single instruction may refer to. So these are all the we can say constraints behind the frame allocation. So constraint behind the frame allocation says total number of allocated cannot be greater than total number of available. There has to be a minimum threshold. Then apart from minimum threshold, we cannot increase the degree of multiprogramming abruptly, because that will increase the number of page faults. And then also we have to see that sufficient number of frames should be there for for execution of at least a single instruction without page fault. This should be the idea. So along with this, many of the frame allocation constraints, there is a category of frame allocation algorithms, or we can say frame allocation techniques. So as we have page replacement algorithms, we also have frame allocation algorithms or frame allocation techniques in operating system. Now these frame allocation algorithms are going to give us the guidelines about how many frames should be allocated to each and to different processes, we can say. And there are 3 types of these frame allocation algorithms in operating system. They are, first is equal frame allocation algorithms. So as the name indicates that the take number of frames and the number of processes. So there is, let us say x number of frames and n number of processes. So x divided by n will be the number of frames given to each and every process. So simply divide the total number of frames by number of process, and this is that particular number is going to be provided for each process. So with 36 frames, 6 processes, we are going to have 6 frames for each one. Now the question which immediately comes up is how efficient is this technique? Is it very logical to assign equal number of frames to all the processes in system, where the requirement of the processes are varying in the sense the size of the processes is varying, then the amount of whether they are into CPU buffer, CPU intensive processes, or whether they are input output intensive processes, that is also a category. Or we can say priority could also be something which is to be considered. So that means a high priority process, if given an n number of pages, similarly a very low priority process is also being given n number of frames, that is also kind of something which is needed to be given a rethought. Because in this situation what will happen, if the process is not utilizing the frames, there will be a lot of allocated but unused frames. On the other hand, there are processes who are using their frames up to their full capacity and also need more. So some is try to understand it this way, that a process is there which is keeping those frames unnecessarily unused, and there is a process which is not getting enough of the frames despite of high activity, and it is resulting in the page fault. So basically in this situation those unused frames will eventually be wasted if a lot of frames are given to a very small process, or if a lot of frames are given to a little operation. So now it comes that it is not always very logical to distribute the number of frames equally. It's not a good idea. So that means if we are not going with equal frame allocation, then there has to be some proportionate frame allocation, or there has to be some priority frame allocation. We will be looking into these two. So if we talk about proportionate frame allocation algorithm, we will be taking the number of frames based on the process size. So if we talk about proportionate, the proportionate is we can say linked to or related to the process size. So big processes, more number of frames will be allocated. For small processes, less number of frames is allocated. Simple. What is the problem here is, the problem in the proportionate frame algorithm is that number of frames may be wasted in some of the rare cases. Although we are assigning less number of frames to the small processes, but still there are some chances that this strategy of frame allocation, which is proportionate frame allocation algorithm, may waste some frames. Now what is the disadvantage? We have seen that it may result into wastage of frames. The advantage in the proportionate frame algorithm is that instead of equally, each operation divides the available frames according to its demand. So this is, we can say, demand supply kind of thing, that whatever is being demand generated, or whatever that is the demand proportionate to the size, then according to the size the demands are being fulfilled. So one frame allocation strategy is equal frame allocation algorithm. That means total number of frames divided by total number of processes, and the number is there, that particular number is being allocated. Fine. Another idea could be this allocation can be we can say proportionate to the size of the process. Bigger the size, more is the number of frames. Lesser the size, less is the number of smaller the size, less is the number of frames. Then the third and the last one, we have priority frame allocation algorithm. So priority, as we say, this is not related, this is something which is not related to the size at least, but yes, according to the quantity of frame allocation and the processes, the priority frame allocation distributes the frame. So for example, when we talk about priority, we have various processes with varying priorities. Some are having high priority, some are having less priority. So let's say a process which is of a high high priority process, that will be allocated more frame, and if that high priority process is requiring more frames, in such cases additional frames will be given to that particular process, and the processes with lower priorities are then later executed in future, and first only the high priority processes are executed first. So that depends upon the not only the priority but also on the demand of the frames which is being generated by the process. So if there is a high priority process looking for more more number of frames, so then in that situation additional number of frames will be given. So a fixed number of frames are already with each and every process, but according to the priority as well as according to the demand, if a high priority process needs more frame, then it can be additionally granted more frames. So apart from the page replacement techniques which we have seen was first in first out, least recently used, most recently used, and apart from that, one for setting the benchmarks which was optimal page replacement techniques. We have also seen frame allocation techniques here. In order to understand the techniques of frame allocation, we have first taken a look into what are the constraints which go through with this frame allocation thing. Apart from this page replacement algorithm, there has to be definite strategies for allocating various number of frames to different processes. That could be equal or that could be unequal, and in equal strategy, similar number of frames is allocated to each and every process. If unequal, now in case of unequal distribution, the distribution can be according to the size, or distribution can be according to, we can say, priority. So now with this constraints of our page replacement techniques we have seen, we have also seen frame allocation techniques. Now what will happen if the frames allocated to a particular process falls below the minimum number of the required processes, minimum number required by the computer architecture. So that means, let us say there is a amount, let us say we have fixed 4 frames per process. Let us say this is a hypothetical figure, and with this swap in and swap out, and we are going with the global replacement strategy, a process is having a low priority process will be taken out, will be its pages will be swapped out, and the pages of high priority process will be paged in. So now the total number of total number of frames is going to fall, let us say, to 1. Now what will happen? The minimum was 4, and now this is having anything less than 4, which could be either 1 or which could be either 2. Now what will happen? In this type of situation, your operating system must suspend the processes execution of this process, but then then this process will be taken out from the memory by freeing all its allocated frames, and this provision introduces a high paging activity. That means a lot of swap in and swap out uh, level of intermediate CPU scheduling is going to be happen. So this technique is, or this situation is known as threshing. We will be taking threshing into detail and its we can say its pros and cons in our upcoming lectures, and we will also understand what actually threshing it, and here is a list of reference which is being used for the preparation of this lecture. Hope you have enjoyed it. I will be taking I will be continuing in the next upcoming lecture. Till then, take care, goodbye.